All right, guys. Today's Monday. The live conference didn't work real well because my internet's in and out. So I'm going to record a video for our quiz review, and then I'm going to post it on YouTube. And you guys will have access to the quiz starting tomorrow morning, and it won't be due until Wednesday at 5. So you have a huge gap to take the quiz, okay? First thing I'm going to go over, 9.3, is adding and subtracting radicals. All right, real quick, remember that in order to be able to add or subtract, it has to have the same index and the same radicand. So we know that this is asking about the square root. There's a 2 there. This is asking about the square root. There's a 2 there. So it has the same index of 2, and it has the same number underneath the radical, which is the radicand. So in this case, I can add these. 1 plus 2 is 3 times the square root of 3. So the fact that they had the same index and same radicand allowed me to add that, okay? All right, so let's try a couple examples. For instance, maybe something like 3 times the square root of 12 minus the square root of 3. Okay, at first thought, it looks like they have the same index of 2, but the radicand's not the same. But this 12 can be simplified. So it looks like they don't have the same radicand, but this one's not fully simplified. So I break it down into 4 times 3. I can take the square root of 4, which is 2, because it's a perfect square. So I bring that 2 out front. 3 times 2 is 6. So now if you look, same index, same radicand, it's okay to subtract. 6 minus 1 is 5 times the square root of 3. Okay, so be careful. Make sure you simplify any radical you can before adding and subtracting. With a fraction, remember we have a quotient rule, same type deal. The square root of 7 over 25 minus the square root of 7 over 100. Remember what the quotient rule says? This becomes the square root of 7 over the square root of 25. This becomes the square root of 7 over the square root of 100. The square root of 7 over the square root of 25 is 5. Square root of 7. The square root of 100 is 10. Okay, now they're just regular fractions. You have to multiply each by 2. So, to find a common denominator, the common denominator is going to be 10. You have to multiply this one by 2 to get 2 times the square root of 7 over 10. And this one already had a common denominator of 10. Subtract straight across, and we get square root of 7 over 10. Okay? So once we got here, this was just like a regular fraction where we have to find a common denominator. And I had to multiply this one by 2. So that's how I got this. Now that they had the same denominator, I went straight across. Okay? Let's try one with a variable real quick. Something like square root of 16x minus the square root of x cubed. 16 is a perfect square. So I take the square root of 16, which is 4, and bring it out front. I can't do anything with the square root of x. Minus. This has an odd exponent. Remember what we do there? We subtract 1 and break it down into x squared times x. Over here, I can't do anything. 4 times the square root of x minus. The square root of x squared is x. Bring it out front. That x stays there. Now look, same index, same radicand. The issue I have is I can't do 4 minus x because they're unlike terms. So I leave it as that. Okay? Remember to have add or subtract radicals, same index, same radicand. All right, let's go to 9.4. Do a couple examples of multiplying and dividing radicals. All right, let's try square root of 3 times the square root of 15. Okay, remember when you're multiplying radicals, if they had the same index, you can multiply the radicand. So this becomes the square root of 45. But I can't box that as my answer because this can be reduced. I know a perfect square that goes into it, it's 9. So now I take the square root of 9, which is 3, and bring it out front to get 3 times the square root of 5. The most basic of things we learned in this section was that squaring something and taking the square root are inverse operations. So if I have something like the square root of 7 squared, that really means the square root of 7 times the square root of 7, which becomes the square root of 49, which is 7. But if you know that taking the square root and squaring something cancel each other out, you can save yourself a little work to get to 7 that way. Okay? We learned to rationalize the denominator. Okay? Meaning that when we have a radical in the denominator, we can't leave it there. For instance, okay? I can't have the square root of 7 is not a perfect square. I can't break 7 down, but I can't leave this square root in the denominator. So I have to multiply the top and the bottom by the square root of 7. The square root of 7 times the square root of 7 is 7. 2 times the square root of 7 is just 2 square root of 7. So remember, rationalizing the denominator means we have to get the radical out of the denominator. How do we do it? We multiplying basically by 1. Square root of 7 over square root of 7 is 1. But that allows us to get rid of the radical. Okay? A couple more examples. All right, let's try square root of 3 over the square root of 18. Okay? First thing I want to do is, I know a perfect square that goes into this one. Let's break it down. So it's square root of 3 over the square root of 9 times 2. It's square root of 3. This is a perfect square, so I can take its square root and bring it out front, which gets me there. I can't box that as my final answer because I have a radical in the denominator. So I have to go, I have square root of 3 over 3 times the square root of 2. In order to get rid of this radical, I'm going to multiply both the numerator and denominator by the square root of 2. Okay? Remember, we just went over, when I do the square root of 2 times the square root of 2, I get the square root of 4, which is 2. I do 2 times 3, which is 6. The square root of 3 times the square root of 2 is the square root of 6. I got the radical out of the denominator. I rationalized the denominator. Okay? And let's do one final example where the denominator has 2 terms and we have to rationalize it. And that's an example of one like this. Square root of 3 plus 2 over the square root of 3 minus 1. When we have a radical in the denominator and it's part of 2 terms, we have to multiply by its conjugate to the numerator and the denominator. Okay? And remember, when we multiply by a conjugate, when we FOIL, the two middle terms cancel the O and the I. So first times first, last times last. So in my denominator, I'm going to get 2. Okay? First times first gives me this. Last times last gives me this. 3 times 1 is 2. Let's do the numerator. Okay? First times first gives me 3. The outer gives me square root of 3. The inner gives me 2 times the square root of 3. And the last gives me 2. Combine your like terms. 3 plus 2 is 5. And these actually are like terms because they have the same index, same radicand, which gives me 3 times the square root of 3. I rationalize the denominator. And the last one I'll go over is one you need to simplify. So if I have one like this, 14 minus the square root of 28 over 6. Square root of 28, think about it. Do we know any perfect squares that go into it? Yes, 4. So it's 4 times 7 over 6. The square root of 4 is 2, so bring it out front. So I get 14 minus 2 times the square root of 7 over 6. I can't box that as my final answer because look at the 2 terms on the top. There's a common factor, a 2. I can take a 2 out of the top, which leaves me with 7 minus the square root of 7 all over 6. And now I can reduce the 2 and the 6. 1 and 3. So my final answer, 7 minus the square root of 7 over 3. Let's review real quick. I simplified the square root of 28 by breaking it down and taking out the square root of 4, which is 2. I recognized that there was a common factor with these 2 terms, a 2. So I factored out a 2, which left me with 7 minus the square root of 7, all over 6. I reduced the 2 and the 6, and that's how I got my final answer. So guys, I'll post this YouTube video, okay? And this will be kind of a little bit more of a review for your quiz that will start tomorrow morning at 8 a.m. And it needs to be finished by Wednesday afternoon at 5 p.m. All right, guys, thank you.